Gary, I know you worked on the Space Shuttle main engines over there in Huntsville. And I mean, to today, they're still the most advanced rocket engines that have ever been built. And it was impressive how well they worked during the Ho shuttle era. We had a few problems with them, but not too many. So, what do you think went into making the SSME so amazing? And, as we were learning them as operators, it was impressive how fast those turbines were spinning. I don't think people realize that one small failure in those turbine blades would have torn the aft end of the shuttle apart. So, why do you think those engines were so successful?
Well, it started with the challenge. Those engines are what they are because of the requirements of the space shuttle. Because it was basically an airplane and the engines had to be relatively small and lightweight. It required a different engine cycle, thermodynamic cycle, than we had ever built before. And that was a staged combustion cycle where all of the fuel that went into that engine went through the main combustion chamber and created thrust. That put tremendous requirements, and because it was a hydrogen engine, it put tremendous requirements on the turbo machinery. And if you remember, there was probably two major advancements in technology with the space shuttle. One was of course, the orbiter tiles, and the other was the high pressure turbo machinery on the space shuttle main engine. So you start with that challenge, and that created a lot of other challenges. We had to do things different than we'd ever done before. We'd always tested components first and then assemble those into an engine system. Well, you can't do that with a staged combustion cycle because the complexity of the test fixture is so much that it's easier just to assemble the engine and put the engine on a test stand. So we started with engine system testing, and the engine, because of its high technology and the turbo machinery, had a lot of problems in the early days. It had rotor dynamic issues. It had thermal issues. We cracked turbine blades. But how we got there was a lot of test. We went through what we used to call a test, fail, fix cycle, where we had to test and find the problems and fix the problems and go into test again as rapidly as we could. It turned out that the more we tested, better we got, the more design changes we made. We evolved that engine, though, over time significantly with new turbo machinery.
So, what lessons did you learn working with the SSMEs that were useful for the design and manufacture of SLS? Because I don't think a lot of people realize that the engines that are going to be long term on the Space Launch System are derivations of the Space Shuttle main engines.
One lesson I learned in working the SSME Space Shuttle main engines was the process of evolution. There's nothing that can compete with the process of improvement, test, improvement, test, improvement. I led a team of rocket engineers that came from the three existing rocket engine companies at the time, which was Rocketdyne and Pratt & Whitney and Aerojet. And what I learned from that is we looked not only at rocket engines, but at airline engines and fighter jet engines. And we found out that they were unbelievably reliable. They operated at temperatures as high as the Space Shuttle main engine, not at the pressures, but they still were under high stress, high energy operation. And those engines would run forever. And it was because they had evolved those engines over time and kept improving them. And they had what they called a technology test bed at all of the engine builders, and they would run all of their technologies through that technology test bed ground test engine before they ever incorporated it into the engines. That led me to believe that the next vehicle should not be a leap in
Oh.
technology if we wanted to actually implement it within the cost ceiling that we had and within the schedule that we wanted to advance a heavy lift launch vehicle. So all of that learning about evolution led me to believe that we ought to evolve into SLS. And that's the reason we have the propulsion system we do. That's the reason we have RS-25s, which is the space shuttle engine, basically. That's the reason we have the solid rocket boosters, because I avoided much of the risk of development by utilizing the propulsion system that have evolved over time. And we'd already invested all of this learning into that propulsion system.